For question 9d, right, I discovered some slight mistakes with the textbook, so I made some changes. So it is asking for the probability that the number is less than 4,000, given that it is greater than 3,000. So this is a conditional probability. So it's written like this. Probability that this number, 4-digit number, is less than 4,000, given that it is bigger than 3,000. So according to the formula that you have learned so far, it is equals to the probability of this number bigger than 3,000 and smaller than 4,000. Okay, bigger than 3,000 and smaller than 4,000. So it is intersect. Divided by the probability that it is greater than 3,000. So for the number of samples that are greater than 3,000, it cannot begin with 1, 2, or 3. It cannot begin with 0, 1, or 2. So that left only 5 more choices. Okay, so 5. After 5, the second, third, and fourth digits doesn't really matter. So once you have taken one digit, one number, 7 is left, then 6 and 5. So the answer is 1050. This will be the sample size for more than 3,000. Then, what is the number of samples which is between 3,000 and 4,000? For that to be the case, it has to start with 3, right? So the first digit has to be 3. So 3 is one. You've taken one choice, 1. So let's start with 1. The first digit is 1. Why? Because you've chosen 3. And after taking out 3, you left 7 more digits, and 7, 6, 5, 7, 6, 5. So the total is 210. So the probability is 210 over 1050. The next one is question 10. Question 10. A hand of 5 cards is dealt from a normal pack of 52 cards. Find the probability that the hand will contain no aces. Okay, so now you're choosing 5 cards from 52 cards. So the total sample size is 52C5. Right? Choosing 5 from 52. Now there must be no aces. So if there's no aces, I take out all the aces. There are 4 of them. So now the deck left with only 48 cards, right? Because you cannot choose any aces, so I take out all the aces. Now only 48 cards left. Then from these 48 cards, I chose 5. So it's 48C5. Therefore, the probability is this value divided by the total value. And for B says at least one ace. At least one ace. So it is similar to question number 8 that the probability of no aces plus the probability of at least one ace is 100%. Now I have already found out the probability of no aces. Right? So 1 minus the answer of A gives me the answer for B, which is at least one ace. Then for C is the probability that you will have ace of spades. Okay, so which means ace of spades must be included. So therefore it is now taken out because it must be among the 5 cards. So the deck is left with only 51 cards. And you will choose the remaining 4 from this 51. Because choosing only 4 because you have taken the ace of spades out. So the size will be 51C4. You're choosing 4 from the 51 because the ace of spades has already taken out because it must be included. So the probability is this value over the total sample size. Now the last question the probability of the ace of spades given that there is at least one ace. So it can be written in this manner. The probability of having ace of spades given that there's at least one ace among the 5 cards. So according to the formula, it can be written in this manner. This is what you're looking for. So it equals to the probability of a spades of A intersect with more than one ace over the probability of at least having one ace. And we already have the answer from the previous questions. And you just divide them.